Hello everyone. We will be talking about ISRO satellites in this lecture session. In the development of satellite technology, India has grown to be one of the best in the world, with our scientists and engineers developing some of the most advanced and cost-effective satellite missions. India has always believed in ISRO's motto of using space technology for the betterment of our society and economy. With this in mind, our scientists are designing and building satellites and technologies required to support our nation. Here we will be looking at some of the most important satellite programs which have been built by ISRO. India's first satellite was the Aryabhatta spacecraft, named after the famous ancient Indian mathematician and astronomer Aryabhatta. The spacecraft was a 26-sided polygon, 1.4 meters in diameter. Except for the top and the bottom, all the other faces of the satellite were covered with solar cells to provide the necessary power. It was completely designed and fabricated in India and launched by a Soviet Cosmos 3M rocket from Kapustin Yar, Soviet Union, on April 19, 1975. Aryabhatta was a scientific satellite and conducted experiments in astronomy, solar physics, and X-ray astronomy. Aryabhatta's success marked a significant milestone in our country's history. With the success of the first launch, in 1979, a second satellite was sent into orbit called Bhaskara 1. After the 7th century Indian mathematician, it was the first remote sensing satellite by ISRO with an Earth observation payload or cameras and 3-band satellite microwave radiometer, short for SAMIR. It was also used to test the performance of indigenously developed solar cells and heat pipes under prolonged exposure. Subsequently, Bhaskara 2 was sent in 1981 with the purpose to collect data on hydrology, oceanography, forestry, and telemetry. Then came the next landmark, that is launching a satellite from Indian soil. The Rohini series of satellites were India's first attempt to launch a satellite on an indigenously developed rocket series consisting of 4 satellites, each launched by the Satellite Launch Vehicle SLV-3. Though failed in the first attempt, but in the second attempt we were successful in inserting the Rohini Satellite 1 into its indented orbit, and thus India became the 7th country to have the capability to build and launch satellites into space. ISRO launched the Rohini series of development satellite RSD-1 and RSD-2, which carried cameras to experiment with the remote sensing technologies. Then came the communication satellites. After the successful launch of Rohini, ISRO wanted to develop a satellite dedicated to communication. This was the Apple satellite. Apple stands for the Ariane Passenger Payload Experiment and was ISRO's first indigenous experimentation and communication satellite. It was launched into geosynchronous transfer orbit (GTO) by the 3rd development flight of ESA's Ariane vehicle from Kourou, French Guiana on June 19, 1981 and boosted into geosynchronous orbit by apogee motor of ISRO derived from the 4th stage of SLV-3. Apple was used nearly for 2 years to conduct extensive experiments on time, frequency, code division multiple access systems, radio network computer interconnect, random access, and pocket switching. We then progressed to the INSAT series of satellites. From experiments and experiences of the Indian-built satellites, ISRO was ready to build a series of satellites that would provide India with the required communication and other capabilities. INSAT stands for Indian National Satellite, which was a joint venture between the Department of Space, Department of Telecommunications, India Meteorological Department, All India Radio and Doordarshan. The INSAT series are multipurpose satellites providing India with capabilities of telecommunication, television broadcasting, satellite news gathering, societal applications, weather forecasting, disaster warning, and search and rescue operations. The INSAT series became operational in 1983 with the commissioning of INSAT 1B, followed by INSAT 2, 3, and 4 series of satellite. With this, we progress to the GSAT series. GSAT, which is an acronym for Geostationary Satellite, was developed indigenously with the aim to be self-reliant in the field of communication. Technically, GSAT comes under the INSAT series. GSAT provides communication support via audio, video, and other digital support services like navigation, teleeducation. GSAT services are also provided for commercial and military purposes. GSAT 7 and 7A are completely meant for Indian Navy and Indian Air Force. Then came the remote sensing satellites. The launching of the Indian remote sensing satellite, that is IRS-1A, and other application satellites with successful demonstration of applications in various fields resulted in evolving the National Natural Resources Management System. It guides and provides the roadmap for the Indian remote sensing program. The Indian remote sensing program began with that is the IIRS satellites, which were dedicated to remote sensing applications and were launched starting with IRS-1A on March 17, 1988 from Soviet Cosmodrome Baikonur. The payload of IRS-1A was a linear imaging self-scanning sensor, LIS-1, that worked on the push broom scanning concept. It also had 2 cameras working on 4 different spectral bands. The main aim of this program was to provide support to the national economy in the areas of forestry, agriculture, water resources, geology, marine and fisheries sciences, and coastal management. The data from the state-of-art IRS-1 series of satellites is used by several countries, and one can access IRS data for free on the Bhuvan portal of ISRO. Today, this series of Earth observation satellites with its imaging capabilities in visible, infrared, thermal, and microwave regions of the electromagnetic spectrum has helped the country realize major operational applications. IRS-1A and 1B payloads have been designed as follows for the different applications. For agriculture, the spatial resolution ranges from 40 to 70 meters. For hydrological applications, it ranges from 40 to 100 meters. Geological applications have spatial resolutions from 100 to 150 meters. Coastal studies, the spatial resolution is from 100 to 150 meters. And land use planning, there is the spatial resolution of 80 meters. The ground systems for monitoring and controlling remote sensing satellites are present at ISTRAC Bangalore and Lucknow ISTRAC centers. Also, the spacecraft control is also done from there. Data acquisition is done at NRSC Hyderabad. Data processing and dissemination and archival is done from NRSC Hyderabad and SAC Ahmedabad. The IRS series of satellites range from IRS-1A to IRS-P6, launched in 1988 through 1999. The instruments on board these satellites are ranging from panchromatic sensors to multispectral sensors on LIS-1, LIS-2, and LIS-3 and LIS-4. Also, we have the wide field sensor, that is the WIFS sensor, with various ranges of spatial resolution, right from 1 to 2 kilometers to about 2.5 meters. Then we talk about the ResourceSat series of satellites, that is ResourceSat 1. ResourceSat is one set of IIRS series of satellites. This series of satellites provides continued remote sensing data at micro level for integrated land and water resource management. They also provide services for advanced areas of crop discrimination, crop yield, crop stress, pest and disease surveillance, disaster management, etc. The payloads on board the ResourceSat series of satellites are LIS-4, LIS-3, AWIFS, and on ResourceSat-1. On ResourceSat-2, along with these, we have the AIS payload, and ResourceSat-2A, we have the VNIR and SWIR payloads as well. The OceanSat series of satellites is a series of satellites which is designed to serve the applications in the area of oceanography and atmospheric observations. OceanSat-1 carried the ocean color monitor and the multi-frequency scanning microwave radiometer. These instruments are used to sense bio and geophysical parameters like chlorophyll content, yellow substance, sea surface temperature, sea surface winds, and water vapor. OceanSat-2 has an OCM and Ku band scatterometer. The scatterometer gathers information about the near surface winds over oceans at a global level. The Cartosat series is a series of Earth observation satellites dedicated to provide high-resolution images for cartography and other purposes. The objective of these satellites is to generate high resolution, that is better than 2.5 meters, panchromatic imagery with high pointing accuracy. The data products are intended to be used in digital terrain model and digital elevation model generation for applications of cadastral mapping and updating, land use, as well as other geographic information system applications. Technology Experiment Satellite was the first high-resolution satellite launched by ISRO. Cartosat-2 is a high-resolution, agile satellite with less inertia used to acquire spot images and strip images up to 200 kilometers. These series of satellites are high-resolution, configured with panchromatic and a 4-band multispectral camera with a resolution better than 2 meters and a swath width of 10 kilometers. Cartosat-3 is an advanced satellite with very high resolution imaging capability. Cartosat-3 provides panchromatic images with a resolution of 0.28 meters and multispectral image in 4 spectral bands with a spatial resolution of 1.12 meters and a nominal swath of approximately 17 kilometers. The radar imaging satellite, that is the RISAT, is the first microwave remote sensing satellite designed and fabricated by ISRO. This mission will facilitate data collection 24/7 and in all weather conditions using an agile synthetic aperture radar payload operating in scan-SAR and strip and spot modes to provide images with coarse and high spatial resolutions respectively. Radar backscattering depends upon the sensor parameters such as frequency, polarization and incidence angle, dielectric constant, roughness and geometry of the target. IRNSS stands for Indian Regional Navigation Satellite System. It is also called Navigation with Indian Constellation, that is NAVIC. IRNSS was developed as a strategic asset for India to provide accurate navigational services to users in India, including the military. IRNSS is a constellation of 7 satellites, and the first satellite was launched on July 1, 2013. In contrast to the global positioning system, the IRNSS provides services to only the Indian subcontinent. IRNSS will provide 2 types of services: standard positioning service, which is provided to all users, and restricted service and encrypted service provided only to the authorized users. The IRNSS system is expected to provide a position accuracy of better than 20 meters in the primary service area. Some of the important applications include terrestrial, aerial and marine navigation, disaster management, vehicle tracking, and fleet management and precise timing. Indian space exploration does not stop at communication, Earth observation, and navigation. The Indian space program has created a prominent place in fields such as astronomy, astrophysics, planetary explorations through its exploration satellite. We have provided here what is possible to, that we have proved here that it is possible to explore the heavenly bodies at low cost, and ISRO has become a role model to the rest of the world. The AstroSat is India's first astronomy mission. On September 28, 2015, it was launched aboard a PSLV from Sriharikota and opened a new window to our universe. The mission aims to study the various celestial sources in X-ray, optical and UV spectral bands. Note here that a single satellite is simultaneously carrying out multi-wavelength observations when most other scientific satellites can observe a narrow range of wavelength bands. Now here you can see that the AstroSat does high-resolution UV imaging for morphological studies of galactic and extragalactic objects using ultraviolet imaging telescope. Soft X-ray imaging telescope made by the Tata Institute of Fundamental Research studies low-energy X-ray sources between the ranges of 0.3 to 8 keVs. AstroSat also looks at other multi-wavelength targets ranging from nearby stars to the very distinct active galactic nuclei. The Mars Orbiter mission, popularly known as the Mangalyaan, marks India's first venture into interplanetary space. MOM or Mars Orbiter mission was designed to explore and observe the Mars surface features, mineralogy and Martian atmosphere. Further, it also performed a focused research in search of methane in the Martian atmosphere to inquire about the possibility or the past existence of life on the planet. The spacecraft, launched on November 5, 2013, arrived safely into the Mars orbit on September 24, 2014. As a result, India made history by becoming the first ever country to reach Mars on its first attempt, and it was done on a very light budget. The payloads on the MOM mission are the methane sensor for Mars, the Mars exospheric neutral composition analyzer, the Mars color camera, and the thermal imaging spectrometer. Chandrayaan-1 was India's first moon mission. The mission had 11 payloads built in India, the UK, the USA, Germany, Bulgaria, and Sweden. Chandrayaan mission, launched on a PSLV rocket on October 22, 2008 from Sriharikota, was designed to collect data about the topography of the moon. The spacecraft was orbiting around the moon at a height of 100 kilometers from the lunar surface. It collected data on chemical, mineralogical, and photogeological mapping of the moon. The data from Chandrayaan helped discover the presence of water on the moon in September 2009. The scientific payloads of partner countries were also carried aboard. The Moon Impact Probe, carrying the Indian flag, hard landed on the moon surface on November 14, 2009. The successor of Chandrayaan-1, Chandrayaan-2, was designed to explore the south pole of the moon. It consisted of an orbiter, a lander named Vikram, and a rover named Pragyan. Launched on July 22, 2019 using a GSLV from Sriharikota, Chandrayaan-2 aimed to study topography, surface mineralogy, and elemental abundances of the moon, specifically examining the traces of hydroxyl and water ice. Instruments used here are the terrain mapping camera, that is TMC-2, Chandrayaan-2 large area soft X-ray spectrometer, solar X-ray monitor, orbiter high resolution camera, imaging infrared spectrometer, dual frequency L-band and S-band synthetic aperture radar, Chandrayaan-2 atmospheric compositional explorer 2, and dual frequency radio science experiment. The Vikram lander was India's first attempt to do a soft landing on the surface of the moon. Had it been successful, we would have been the fourth country to achieve this feat. It was named after Vikram Sarabhai, the father of Indian space program. The Indian mini satellite IMS-1, previously called the Third World Satellite, is the first microsatellite fabricated for remote sensing application purposes. This satellite can be launched with a PSLV, which is developed as a versatile microsatellite bus. IMS-1 is designed with aluminium honeycomb sandwich panels as a cuboid structure with a bottom deck, top deck, and 4 cross ribs of size 552 mm by 600 mm by 600 mm. Thermal control is achieved by passive means using semi-active elements like paints, MLI, OSR, and thermal tapes, thermistors, and thermocouples are used for temperature monitoring. India has developed and is launching its first nanosatellite, namely INS-1A and INS-1B. The goal of the mission is to develop modular nanosatellite bus in the weight range of 5 kg payloads and volumes 185 by 185 by 160 mm, provide up to 10 watts of power for payload operations. The benefits of nanosatellites are that they are low cost, which also make constellation missions possible, relatively short development period, capacity to launch on demand, ideal for small scientific payloads, multiple satellites can be launched in one launch, short time scale to obtain scientific results, devices have comparable capabilities, commercial off-the-shelf products and consumer products can be generated, plug-and-play technology comes into play, and there is international cooperation. ISRO supports student-led satellite programs by launching student-built satellites into space. Under the guidance of ISRO, universities design, fabricate, test the satellite bus and payload, and deliver the integrated spacecraft for launch. ANUSAT, that is Anna University Satellite, was the first satellite built by Madras Institute of Technology, Chennai under this program. It was launched on April 20th, 2009 on a PSLV rocket. StudSat is the first PICO satellite developed in the country by a consortium of several engineering colleges in Karnataka and Andhra Pradesh. StudSat launched on a PSLV rocket on July 12, 2010, weighed less than 1 kg. The primary objectives of the program were to promoting space technology in educational institutions, encouraging research and development in miniaturized satellites. The latest in the student satellite program is UnitySat-1, a combination of 3 satellites which are 0.25 unit-sized CubeSats built by the Unity program of 3 different Indian institutions, JIT-SAT by the JPR Institute of Technology, Sri Perumbudur, GHRCE-SAT by the GH Raisoni College of Engineering, Nagpur, Sri Shakti-SAT by the Sri Shakti Institute of Engineering and Technology, Coimbatore. I hope you enjoyed this lecture session. Thank you.